Welcome to Unit 2, Lesson 3. This is Part 1, the first video for Lesson 3. And we are going to go over polynomials, factoring them, solving them, and getting some information and kind of sketching them, knowing what they look like, etc., etc. So a little bit more polynomial work. In Unit 2, Lesson 2, we kind of introduced ourselves to polynomials a little bit more. It's kind of what we've been doing this whole unit so far, and some radical work. But let's get started, okay? And we're going to start by reviewing some factoring techniques, okay? Now, the first thing for number 1 here, in case you forgot, and these shouldn't take too long for us to do. We've done these before. This is review, okay? So the first thing I'm going to do in my mind is I'm always going to try and look for a greatest common factor if I can. I know 5 goes into each one of these numbers, and I can take out at least 2 x squareds. So I'm going to divide everything by 5x squared. And I take my greatest common factor and place that out front. And what's left would be 3x squared minus 4x plus 7. All right. Now, I don't know if I can factor that any further. All right. So what I'm going to do is try slip and slide at this point. I'm going to slip the 3 out back. And I now have x squared minus 4x plus 21. Okay, and this 5x squared just comes for the ride. Now, how will I know if this is factorable or not? If I can factor this, which I've written in red, in product sum, which means 2 numbers that multiply to 21 that add to -4. If I can factor that, then it's factorable. If I cannot factor it at this point, it is not factorable, and what I wrote here in green would be my final answer. That would be completely factored. So let's try this. Well, you know what? X minus 7 and x plus 3. Okay, -7 times. Ooh, wait for it. Oh, that is not good. In fact, that can't be factored at all, can it? -7, and I was doing my check in my head, times a positive 3 would be -21, not positive 21. So that's a boo-boo. So guess what? This cannot be factored, which means I should not have even done the slip and slide, which means the best thing I could have done, and it would be easier to do it this way. I shouldn't have even, I can't even slip and slide. So instead of trying to slip and slide like this, that was not factorable. And that's my answer right there. Greatest common factor. On to the next one. All right, so number 2, I can't factor out a greatest common factor, so I'm going to try slip and slide here. 6 times the back, so I have x squared plus 11x minus 60. And again, 2 numbers that multiply to -60 that add to 11. Well, that would be x plus 15 and x minus 4. If I multiply these 2 numbers, I get -60. And if I add them, I get positive 11. And here's where everybody struggles. You brought the front number out with multiplication. I need to bring it back in with division. All right? And now I need to simplify these fractions. So I have x plus 5 halves. And I have x minus 2/3. Okay? And the last step for slip and slide is bottoms up. Bottoms up, bottoms up, up. Okay, so there we go. 2x plus 5 and 3x minus 2. Yahtzee. Let's go on to the next one. Again, if you want to pause this video and do these on your own and then check your work and as you watch me do these, because if I was watching you while you were watching my video, that would be kind of creepy. Anyways, number 3. Oh, there's no 2 numbers that multiply to be 25 that add to 10. Oh, that's easy. X plus 5 times x plus 5. This is a completely acceptable answer, but if it was multiple choice, it would probably be written like this, x plus 5 squared. All right? And speaking of squares, I am recognizing that there is a 4 and a 9 and is separated by a minus. This is a difference of perfect squares. What's the square root of 4x squared? It's 2x. What's the square root of 9? It's 3. And since there is no middle term here, it needs to go bye-bye, which means I need a plus and I need a minus. Factoring is so critical as you move forward in math, it's crazy. Right? So don't just remember these for this unit and forget them. You're going to keep on needing to know these things in pre-calculus and calculus no matter where you go. All right, last one, number 5. Factor by grouping. How come I'm going to try grouping first? I cannot do any of the above methods because those are quadratics. This is not quadratics, it's cubic, meaning the degree is not 2. There are not 3 terms here. There are 4 terms here, okay? The only thing I could have maybe tried to do was pull out a greatest common factor, but I can't even do that here. So what I'm going to do is pull out a factor of each one of these parentheses. So I can factor out an x squared here. That will leave me x plus 2. And I want to try and get the same x plus 2 left after I factor something out of this. And I would have to factor out a negative 3, not a positive 3. If I factor out a positive 3, that will leave me with negative x minus 2. That's not the same. If I want these signs to flip, I have to flip this sign. Okay? So, I'm not done. All right, so now I'm going to take these and factor that out, x plus 2, and what's left, x squared minus 3. This is not a difference of perfect squares, so I'm going to leave it just like that. That is factored completely. And whew, that was a quick little refresher. All right, you like my Polar Express train? It's the bestest. Anyways, it's close to Christmas time here. It's actually December 14th. I don't know when you're watching this video, but I felt a little festive, so I wanted to put a Polar Express in there, and you'll see what happens in a moment. But when we are factoring the sum and difference, it's not 2 perfect squares, okay? 2 perfect squares, the difference of 2 perfect squares was right here, okay, on the previous slide. This is 2 cubes, okay? They're the sum and the difference. It doesn't have to be a minus sign between them. It could be a plus or a minus sign, okay, of cubes. So that's anything cubed, all right? So, are you ready? They both look very similar because there's like a formula you can use here, and you kind of just plug in numbers. It's really not as complicated as you think it's going to be. All right, so choo-choo, bye-bye. See you later, Tom Hanks. Anyways, don't mind this red, green, and blue circle. They both look very similar. What's under those circles, I'm going to show you in a moment, would be the only difference between the two. They start out with, okay, I'll do this in purple, A and then some operation in B. They both start out that way. Then look how they both end. A squared something something, AB something something, B squared. It is the same exact thing. A squared something something, AB something something, B squared something 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 something. All right? The only difference is as follows. Okay? I'm wondering if I should make this comment beforehand. Yes, I will. Where do the A and the B come from? Okay? Whatever is here is a perfect cube. Let's say it's x cubed. I take the cubed root of it, and I just get x. Okay? The first term. Okay? I take the cubed root of this, and that's my A value. I take the cubed root of this, and that's my B value. Okay? And I write those there. I write them here. I take my A value and square it for here. I multiply A times B here, and so forth. I think it's pretty straightforward. And we'll do some examples. All right? So the million-dollar question is, what's underneath these signs? These circles, I should say. All right. If it is A plus B, it will start with the same exact sign. So if we have a minus here, doesn't that mean it should also be the same sign here? It is. So this first sign in both of them, it's the same as what you're given. All right? The next sign is always the opposite. So if I look at my first one, my next one, well, if it's it should be minus, shouldn't it? Boom, and it is. Okay? If I look down here and that's a minus, well, it should be the opposite of that. It should be a plus, right? It is. So we start out the same. Then whatever is next should be the opposite of what we're given. Opposite of what we're given. Okay. And last but not least, this one, always plus. What about the next one? Can I say always plus? So this last one is always a plus. So the first sign we have here, it's the same sign as we're given. The next one we have here, whatever's next, it should always be opposite of what we're given. And this last sign here should always be a plus. Everything else is the same. AB, A squared, whatever. Same, opposite, always plus. All right? So I have a lot of colors and writing here, and there's a lot of explanation. If you need to write any note to yourself that I don't write on this board, by all means, write it to yourself. As long as you write it to yourself so that when you're reviewing it, you understand what your note to yourself means. That would be really weird if you were trying to communicate something to yourself and you couldn't. What would that say about your communication skills? Oh, man, I'm so glad I teach you math and not English. So let's go on to the next one. Let's do some of these. All right, I've got our equations on the top of the board here, and these are perfect cubes. So how do I find what my A and my B is? All right, my A value is going to be the cubed root of my first term. That's just x. My B is going to be the cubed root of my last term. And that is just 1. Now. I don't care about the sign. And I will get, when we do number 2, I'm going to explain that in a moment. All right? Like, I don't care if it's a plus or minus 1 when I'm taking the cubed root. I'm just taking the cubed root of whatever this is. I'm not considering the sign. So for number 2, I'm just going to take the cubed root of 27. I don't care about the minus. The sign will take care of itself when I fill in the same, the opposite, and just always a plus. Okay? So, let's get going, shall we? Shall we? So, let's fill in. It's always A and B. My A is x, my B is 1. The sign should be the same, right? So it's a plus. Okay. Then I take A and I square it. X squared. I take A and multiply it times B. X times 1 is just 1x. And then I take my B value and square it. 1 squared is 1. And what about my signs? This should be the opposite of what I'm given, so it's a minus. And this is always a plus. Always, 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 always. That's my answer. If you want to go ahead and start to do some of these, by all means, go ahead. Pause this because I'm about to do this. It's about to get real here. So, my A is the cubed root of x cubed. That's x. My B, it's the cubed root of 27, which is 3. I don't care about the minus sign now because my signs will take care of themselves right here. In fact, let's fill out the signs first. In my first parenthesis, it should be the same. I have a minus between them. The first sign in my next parenthesis should be the opposite. The opposite of minus is plus. And my last parenthesis, or my last sign, is always a plus. So now let's just fill in the numbers. Now look it. There's a minus sign here. It should be minus plus plus. Minus sign here. It should be minus plus plus. So let's fill this in. It's A and B in the first two. So my A is X, my B is 3. A squared, so it's X squared. A times B, that's 3X. And B squared, 3 squared, that's 9. Okay? Now, I'm going to tell you something. This is factored completely. Don't stare at this parenthesis right here. I'm telling you this right now. This is never factorable. Don't ever try and oh, well, maybe they're tricking me. Maybe I can factor that second quadratic. No, you cannot factor this either. After you do this perfect cube, it is done. There won't be a second factoring, okay? On to the next one. Number 3. Oh, I like this one because now my A value is the cubed root of 8x cubed. Well, the cubed root of x cubed is x. The cubed root of 8 is 2. So my A value is 2x. My B value, what's the cubed root of 125? I'm just going to say 5, mister, because it ends in 5. You would be right. All right, so let's do this thing here, blah, blah, blah. The sign is going to be the same, so it'll be a plus here. Okay, now the opposite sign, and always a plus. I mean, it's that simple. Okay, I put my A value here, put my B value. A squared. Please do not write 2x squared. That is just squaring the x. That is not squaring the entire A value. I have to square the entire A value. I have to square the 2, which is 4, and the x. All right? So, now my middle term, I need to multiply A times B. 2x times 5 is 10x. And the last one, that's my B squared. So it's 5 squared. Okay, that was a good problem. It introduced you to a lot of different possibilities. And now we're going to keep on rolling. What? Okay, oh, easy. Easy. This should have been the second one we did. It's so easy. Okay, this is going to equal something, the sign is the same, something, the opposite, something, always plus. That'll never change. Okay, so my A value is the cubed root of x cubed, which is x. And my B value is the cubed root of y cubed, which is y. Oh, x times y. Okay, A squared, so that's x squared. A times B, that's x times y. B squared, it's y squared. Boom, done. Now, you see how I write this stuff here? I write this so you see where these numbers are coming from. You don't always have to write those numbers down. I like to see them in front of me. You don't have to, but I want you to do it until you get good at it. If you're not good at perfect cubes and perfect squares and things of that nature, you need to do stuff like this so you keep on seeing it repetitively in front of your face. Number 5. Let's get going. That's right. Oh, curveball. What's the cube root of x to the 6th? Okay. I'm really just dividing it. So it's x. I'm going to turn that back into a fraction exponent. That's x squared. My A is actually x squared. And my B, the cube root of 1, is 1. Woo! The sign is the same. It's a minus, so I'm going to keep it a minus. Opposite, always a plus. So I put my A value, and I put my B value. Now, I have to square my A value. That means it's x squared, and I have to square it. that actually gives me x to the fourth. Okay? Now I multiply a times b. 1 times x squared is x squared. And the last one is b squared. If I take 1 and square it, it's still 1. Now, I'm going to create a little room here. Visca, what are you doing? You said we would never have to factor the last term. You will never, and I'm going to repeat this, ever have to factor this. That is factored. But look at this. Isn't that a difference of perfect squares? That is technically x minus 1 times x plus 1. This never does change this one. That's a bad arrow. That would still be x to the fourth plus x squared plus 1. That is completely factored. They threw you a curveball there, and you swung and you missed. But that's all right. I'm here as a hitting coach. You're going to knock it out of the park when you see it on your next assessment. We got time for one more. Solve a polynomial by factoring. You are just going to factor it just like we did in the first page, the review, and just set it equal to 0. So our factoring, we're going to T-bone. We're going to solve each one of those. Booty cheek and T-bone time. Never goes away, people. Never goes away. So we're going to write our equation, set it equal to 0. Okay, this is our equation, whatever it is. Set it equal to 0. And then we're going to factor it. And they say we're just going to use, it's called the zero product property. That just means T-bone it. Set each one equal to 0 and solve. Okay, this just means set it equal to 0, set each factor equal to 0, and solve it. That's all we're going to do. So let's take a look at example 1. We have, all right, we're going to set this equal to 0. I'm going to bring my 3x over. So I've got 2x cubed minus 5x squared minus 3x equals 0. So now I'm going to factor out an x because I can take one x out of everything. 2x squared minus 5x minus 3 equals 0. Slip and slide. Bang. My x comes for the ride. Ride, slip and slide. Okay, so 5x minus 6 because I multiplied the back times 2. This should be review for you guys. Two numbers that multiply to negative 6 that add to negative 5. Well, that would be x minus 6 and x plus 1. X just comes for the ride. And because we multiplied the 2 out, we got to divide the 2 back in. So now I have x times x minus 3. I cannot simplify this, so bottoms up, 2x plus 1 equals 0. Now I've got to T-bone these, all of them. This is also a factor. So I've got x minus 3, and 2x plus 1 equals 0. I set them all equal to 0 and solve. X equals 0. Done. X minus 3 equals 0. If I add 3 to both sides, my x would equal 3. Boom. Done. 2x plus 1 equals 0. I subtract 1. So 2x equals negative 1. And then I divide by 2. Bang. So x equals negative 1/2. My 3 roots are 0, negative 1/2, and 3. Okay. So how do I find my y-intercept? I make my x equal to 0 and simplify. So, if I take my original equation, all right, I take my original equation, I'm going to say y equals this. Before we even factor anything out, when we got everything on one side, 2x cubed minus 5x squared minus 3x. If I made all these x's zeros, anything times 0 is 0, isn't it? Y would equal 0. That is my y-intercept. My behavior, well, this is a cubic, and I know that cubics, if they're positive, they go down and to the left and up and to the right. If this is my Like, I don't know where it's going to do in the middle, but I know that's what's going to happen. Okay? Because I have an x cubed as my lead term, and it's a positive number in front of it. This is all review up to this point. So now they want us to sketch this. Okay? They want us to sketch this. My 3 zeros. Yep. Woo. The board does. Yep. Woo. One more time. 0, -1/2, and +3. Those are my x-intercepts. What I solve for, my solutions, my roots, are also my x-intercepts. I know my graph is going to cross the y at 0 right here. That's my y-intercept. And I know it's going to go up forever this way and down forever this way. Okay, I'm sketching it. So maybe it goes boop, boop, boop like that. All you've got to do is make sure it crosses your 3. Okay, all you got to make sure is that it crosses your 3 x-intercepts, 1, 2, 3, or your 3 roots or solutions, and it does. You got to make sure it crosses your y-intercept, which happens to be 0 as well, which it does. And you got to make sure the ends are exactly what you wanted them to be. It goes up and to the right and down and to the left. And that, my friends, is a good sketch. Now, the rest of these problems I'm going to have you guys try on your own, so I'm not going to go over these. But it's the same thing. Solve this, find the roots or the solutions. That's where it's going to cross your x-intercept. Find the y-intercept by making all my x's 0 and figuring out what that is. And then figure out the end behavior. And then just draw that sketch with those characteristics. All right? Good luck. Wow. We did one lesson in one video. Strange. I'm getting weak, soft in my old age. Anyways, I hope to see you again. And by see you, I mean, have you hear my voice, because I've got a godlike complex. And it makes me happy. And I'll see you for Unit 2, Lesson 4. Take care. Godspeed and happy holidays.